Balance a chemical equation. So we have carbon dioxide plus water make glucose and oxygen gas. This is the formula for photosynthesis. So first step in balancing an equation is to write out the equation in its formulas. So carbon dioxide, you should know, is CO2. Water, you should also know, is H2O. Glucose, I wouldn't expect you to know that one, but here it is. C6, H12, O6, and oxygen gas. So there we go. Balancing an equation has to be what goes in must come out. So if you look here, by inspection we can tell there must be something wrong. We're only starting with 1 carbon, yet we have 6 on the other side. So where do those other 5 come from? Same thing with the hydrogen. We only have 2 hydrogen to start in the H2O, but we have 12 hydrogens in glucose. So where did they come from? Water has a similar problem. So there must be something wrong with this equation, and what balancing does is it basically fixes these problems by saying maybe it's not just 1 carbon dioxide plus 1 water makes 1 glucose and 1 oxygen gas, but instead it's probably that several carbon dioxides plus several waters will make glucose and oxygen, so that we have the same number on both sides. I want to be very clear that balancing equations there is no recipe for. If you can follow this will only really work for this one equation. The steps are the same, but they're by no means are you going to do the same things each time. So, step that you should do next is count up your atoms. Figure out what you have and how many of each. So we have carbon, we have oxygen, and we have hydrogen. Note that that is the same on both sides. You can't start with beryllium, say, on one side and end with carbon on the other. If you're starting with carbon, oxygen, and hydrogen, you got to end with carbon, hydrogen, and oxygen, just in different forms. And that's what we see. So, atom up on both sides. On the reactant side, we have 1 carbon. We have 1, 2, 3 oxygens, and we have 2 hydrogens. On the product side, we have 6 carbons. That's quite a bit more. We have 12 hydrogens. Make sure that goes in the right box. And we have 6 oxygens with the glucose, and then 2 more in the oxygen gas, which adds up to 8. So, something must be wrong. We can't possibly have more carbons, oxygens, and hydrogens to end with than when we started. So this is where it gets difficult. You'll do this step out for each equation, but now you're going to have to figure out how can you turn 1 into a 6, a 3 into an 8, and a 2 into a 12. Or sometimes you can't even do that. You'll just have to make sure that your numbers on the reactant side are the same as the numbers on the product side, and they may not be, any of them be the same. But let's start with something simple first. Seems easy enough to me that if I put a 6 in front of my carbon dioxide on the reactant side, that changes my number of carbons to 6. And what that 6 in front literally means is it takes 6 carbon dioxides to make this reaction work. Not just 1, but 6 of them. So try to visualize 6 carbon dioxides, 6 C's with 2 O's attached to them each. So that then changes our number of oxygens. So instead of having 3, we have 2 times 6 is 12, which is how many oxygens there'd be in 6 carbon dioxides, plus an extra 1 here with the water. So that adds up to 13. So that didn't help us with the oxygen, but it did balance out our carbon. So we're happy there. 6 to start with, 6 to end with. Now I look at this and I say to myself, alright, turning an 8 into a 13 for the oxygens is going to be difficult because I can't multiply that by 2, and there's no such thing if I can't put 2.5 or something in front of something because there's no such thing as 0.5 molecules. But what I can do is put a 6 in front of the waters here as well, which means we need 6 waters to go with those 6 carbon dioxides. That changes our number of hydrogens to 12. But it also changes our number of oxygens again. So now we have 6 oxygens with the waters and 12 more with the carbon dioxides, which adds up to 18. So now our hydrogens are balanced, but our carbons are balanced, but our oxygens are not. So now we have 18 oxygens on the reactant side, but only 8 on the other side. So you got to ask yourself, I got oxygen with the glucose, and I also have oxygen by itself. If I put a number here in front of the glucose, I'm going to ruin my balanced carbons and my balanced hydrogens, because I'll be changing the number in the glucose as well. So I want to think of a number I can put in front of this O2, so that'll only change my O2 number and not my or my oxygen number, not my carbon or my hydrogen numbers. So if I put a 6 in front of here as well, I have 6 times 2 is 12, plus 6 more with the glucose makes 18, and this is now a balanced equation. So what this means is, for photosynthesis to take place, you need at least 6 carbon dioxide molecules to collide with 6 water molecules. You'll make 1 big glucose molecule, and you'll release 6 oxygen molecules back into the atmosphere, which is when plants breathe back out the oxygen. There it is. I want to be clear as well that the 6 in each of these cases is simply a coincidence, that you could get any numbers to go in front, but what you need to do is have both your reactant and products numbers be the same on both sides in the end for each element in your equation to have a completely balanced equation.